Hey guys, let's take a look at this classic problem, Fibonacci number. Yeah, let's just jump straight into it. The naive solution is very simple. If n is 0, 1, we just return n. The other case, return fib minus 1 plus minus 2. So this should be okay. It should be working. But it's not very fast because there are a lot of duplicate calculations. For example, if we're calculating f4, we need to get f3 and f2, but f3 also get f2 or f2, so f2 is calculated twice. It's very not performant. The first solution is just we can use a map to store the result. Custom map equals new map. When we are calculating, we check if the map has the result. If not, if there is, we just return. So if map has n, we just return map get n. The other cases, we need to first calculate it. Cast the result equals this one, and then we map set n result, and then we return result. This is so-called memorization. Yeah, but still there is problem. Yeah, the problem is that this doesn't look very clear. Let's write a decorator to like memo, a memo, which will help help memorize the function, the parameter, the mappings between the parameters and the result without intrusive changes to the original implementation. Like this, we should return arg. We suppose there is only one arg, okay, for now. So it should be, there is an internal map to hold the result. Return map has arg and return map get arg. It's not, we just call the function called the arg, and then we define the Fibonacci function. As the first try, return fib minus 1 plus fib minus 2. This is the implementation for Fibonacci, right? So we add it to memo, and now we can just call fib and wait a second. Func map, if map has arg, okay, get. If not, we set func, this is wrong. If map has arg, map return map get arg. In the other cases, this result equals func arg. map set arg result, return map get arg. We just extract the common logic into a separate function. Okay, so the here, this is right, I think. Run the code. Huh? Maximum call size, maximum call stack. What? So this is right? Ah, God. This is not in, but I. So the result, is better. But there's still a problem that the memo doesn't actually store all the results from 0 to that number. So for Fibonacci, we might not need them, right? So in order to reduce the extra space we need, we can just calculate it from Fibonacci from the beginning, and just store the last two results. So we will say if n equals 0 or n equals 1, we return n. In the other cases, we use prev last 2 equals 0, 1. Oh, because we already stored the 0, 1, we don't need this. For let I equals 2, smaller than n, I plus plus. Last 2 push, last 2 0 plus last 2 1, last 2 shift. Okay, now we can return if n is bigger than 0. Even for 1, we can always just return last 2 1, last 2 0. Oh shit. Yeah, it is accepted, and it is not that fast. Anyway, I think this is the best approach. That's all for this one. See you next time.